Hello and welcome to a course on reinforced concrete structures design and drawing. I am Praveena Rao, Assistant Professor in the Department of Civil Engineering, Institute of Aeronautical Engineering. So today we are going to discuss on the topic Introduction to Reinforced Concrete Structures. Coming to the course objectives, it may be outlined into three objectives. The first objective can be the basic design concepts for reinforced concrete structures, starting with the historical development and coming up to the latest limit state theory. The second objective is the Indian standard codal provisions and refreshing on the bending and shear theory. The third objective is the behavior of reinforced concrete components and the systems subjected to gravity as well as lateral loads, designing of different structural members, beams, for example, beams, columns, slabs and footings. So these are the course objectives of reinforced concrete structures design. Coming to the course outcomes. So what will be the students getting from this course? So at the end of the course, students should be able to, the first course outcome will be to explain the concept of the stress block, parameters and use the design concepts of working stress method, limit state method for the design of different structural components. The second course outcome would be to recall the basic concepts of singly reinforced beams, doubly reinforced beams, flanged beams, that is T-beams and L-beams are called flanged beams. And coming to the materials, then what would be the stress strain curves and the safety factors to know the properties of concrete structures. The third course outcome would be to explain the concept of bond, shear, anchorage, development length and the different sections for shear and torsion and how the design would be for residential, commercial and industrial structures. The fourth course outcome involves the solving of problems for design of reinforced concrete slab sections, conforming to the Indian Standard Codes IS 456-2000 and obtaining the reinforcement detailings for load-bearing members. The fifth course outcome involves the development of the concept of axial loading for uniaxial and biaxial bending of vertically loaded members. So when we talk about vertically loaded members, it involves the analysis of columns and design of reinforcement for columns. The sixth course outcome includes the design and reinforcement of structural sections for isolated footings, combined footings and staircases for obtaining its reinforcement details. So this course is divided into 5 modules. The first module involves the introduction to the limit state design. The second module includes shear, torsion and bond. Module 3 is design of slab. Module 4 is design of columns. And module 5 is design of footings and staircase. So coming to the course overview. So let us begin with what is reinforced concrete structure. Any structure which is made up of concrete and it is provided with reinforcement is called a reinforced concrete structure. So what is the definition of concrete? We could say that concrete is a most versatile construction material used all around the world. So what is concrete? Concrete is a composition of cement, sand and coarse aggregates when mixed together with admixtures and water. So when we use concrete with some kind of reinforcement in the form of steel bars, it is known as reinforced concrete. So what is reinforcement? Reinforcement is provided to make the material stronger in tension. So reinforced concrete is making concrete stronger with the help of steel bars. So what is concrete? Concrete is the most versatile construction material which is reinforced with the help of steel bars. So that is reinforced concrete members. So let us look at the example of reinforced concrete member, that is a reinforced concrete beam. So let us see here. So as we should know already, we have seen in the course strength of materials, right? What is tension and what is compression. So when there is tension is when there is a pulling force, right? This is called tension. And what is compression? Compression is a compressing force, right? So when we talk about concrete, concrete is an element which is weak in tension, whereas it is strong in compression. So if you look at the figure here, there is a reinforced concrete beam and there is a uniformly distributed load, that is W, and it is kilonewton per meter, right? So when there is a concrete beam which is carrying a uniformly distributed load W in kilonewton per meter, this is NA is the neutral axis, right? And when there is this uniformly distributed load acting on this concrete beam, the beam is going to start bending downwards, right? When it starts bending down, you can see that the top fiber, this is called the top fiber, right? This top fiber is going to bend in this fashion. Due to this, there is going to be compression on the top fiber. So the top fiber is under compressive loads, and this bottom fiber is, you can see it is stretching outwards. That means there's going to be tension, right? So this concrete beam under a uniformly distributed load of W kilonewton per meter is going to bend as per the bending theory, and the top fiber is under compressive forces and the bottom fiber is under tensile forces, leading to cracking at the span of the bottom fiber. So this is the behavior of a reinforced concrete beam under a uniformly distributed load. So the objective of this course is to design the different structural elements. And what are the different types of structural elements? There is the slab, which undergoes bending. There is beam, which undergoes bending moments and shear forces. Columns, which have axial forces and bending moments. And footings will have shear force. So what do you mean by design? Designing is to plan or to show the structure before it is being constructed. So when we say design, that means we are designing a structure. We mean by we are planning it out. What should be the geometrical or the reinforcement detailing of that structural component before it is constructed. So designing is the phase before construction. We have to plan and we have to decide what should be the concrete grade, what should be the reinforcement, how much should be the reinforcement. That is called as the designing of a structural element. Coming to design codes. So how do we know how to design these structural members? There has to be a standard procedure to be followed by all the construction companies, right? Because there has to be a standard measure for the safety and serviceability of all the structures. It has to be serviceable. When we say serviceable, it means that the people who are occupying the structure should be at utmost safety, right? So the design codes, the code serves at least 4 distinct functions. So what are these design codes? What is the function of these design codes? So firstly, that the structure should provide adequate structural safety. That means when there is somebody in the building, it should not collapse or there should not be too much deflections. It should be within the permissible limits for the safety and serviceability of the structure. So first requirement of any structure is that it should be structurally safe. Second point is to render the task of the designer relatively simple. So the task of designing should be relatively simple. The third point is the code ensure a measure of consistency among the different designers. So different cities, different towns, different villages, all across the different states in the country, all the buildings should be constructed with consistency, right? The code is going to provide consistency in the design procedure. So this is giving you consistency throughout the country. We are all following the same design codes for construction and have some legal validity. So we also have to validate the design procedures. It should have valid legal legality in construction. You cannot have illegal construction practices. So you have to follow these design codes for the construction of different buildings. So what are the functions? For adequate structural safety, to make the task of the designer relatively simple, to ensure that the code, there is a measure of consistency among the different designers and have legal validity. So coming to the methods of design. So what are the methods of design? The RC structure should be designed to fulfill its intended purpose during its lifetime. And what are the requirements of an RC structure? Firstly, as we discussed already, safety. Safety in terms of strength and stability. So it should have adequate strength and should be stable. When we say stable, that means it should not cause a lot of deflections or any kind of displacement when it is under service. Serviceability in terms of stiffness and durability. That means the structure should have adequate stiffness and it should be durable. And the last requirement of the design method is that the structure should have enough economy. The structural design should be economic so that there is limited, because construction of different structural elements requires lots of funds. So it should be economic. So safety in terms of strength and stability, serviceability in terms of stiffness and durability, and economy. So these are the requirements of the structure. So RC members can be designed by the following methods. So methods of theoretical concepts approved by the code of practice and by experimental investigations. So the commonly used structures are designed by theoretical methods. And what are the methods? The first one is the working stress method. And it was also called the modular ratio method. And the second one is the ultimate load method. It was also known as load factor method. So these are the old methods of construction which are now upgraded to the limit state method of design. Currently in India, we are practicing the limit state method of design. The working stress method and the ultimate load method are obsolete. Currently, we are following the limit state method. So let's just discuss about what is a working stress method. So it is a traditional method not only for reinforced concrete but also for structural steel and timber design. So even steel structures and timber structures were also constructed by following this working stress method. This method ensures adequate safety by suitably restricting the stresses. So the stresses in the material are restricted and induced by expected working loads on the structure. Based on the concept of modular ratio, that is the ratio of the modulus of elasticity of the steel to that of the so this method is based on the modular ratio. And what is the modular ratio? Modular ratio is equal to ratio of the modulus of elasticity, modulus of elasticity of steel divided by modulus of elasticity of concrete. So this is the modular ratio. So this method, working stress method, is based on the modular ratio, which is the ratio of the modulus of elasticity of steel to that of concrete. Both steel and concrete are acting together. So this is the assumption that both are acting together. This is the working stress method. So if we look at the stress strain curve for mild steel bars, so we have also come across this diagram, the stress strain curve of mild steel bars in the strength of materials course. So we can see that initially when the stress and strain is increasing, this is proportional, right? They are directly proportional up to the point A. From here on, the diagram, you can see the stress is here at B, it is yield stress. It is the material is yielding. And then it comes down to D and then it slowly goes up to E until where E is the ultimate stress. That means the material has reached its ultimate strength and it is going to start leading to fracture or failure. So at point F, you can see that is the rupture strength. That is the ultimate. The fracture, at fracture, what is the ultimate strength? So this is called the linear range. That is because here the curve is linear, right? It is directly proportional. The stress and strain are proportional. So it is called the linear range, and then it is going to change. So this region is called the elastic region. Elastic region is the linear range, is called the elastic region, and this is partially plastic. So in the elastic region, you have that the stress is proportional to strain. So that means whatever strain is occurring, it is reversible. And when we say plastic, whatever strain is taking place, it is not reversible. That's why it is called plastic. It's following the Hooke's law. In the elastic range, it's following the Hooke's law. So it is assumed that the structural material behaves in a linear elastic manner. Since the allowable, what do you mean by allowable? That is, the permissible stresses are kept below the ultimate strength of the material. So the allowable stress is always below the ultimate strength of the materials. That is called the linear elastic design or the behavior. So coming to something, there is a term called factor of safety. So factor of safety is the ultimate stress by the working stress for concrete. Similarly, you have for steel, you have yield stress. You have yield stress divided by the working stress in steel. So factor of safety for steel is 1.8, whereas the factor of safety for concrete is 3. So what are the demerits of working stress method? That it does not allow real strength nor gives the true factor of safety. So these are the demerits, that it does not show the real strength of the element. So the working stress results in larger compression steel compared to limit state method, and when load combinations are occurred, working stress method fails to explain. That means when there are combination of loads, if there is a point load as well as there is a rolling load. So when there is combination of loading, then the working stress method is inadequate. So because of creep and non-linear stress strain curve, concrete does not have definite modulus of elasticity. So these are some of the demerits of working stress method. Coming to what are the merits. So it is one of the most simplest method, and the results in larger sections, which gives better serviceability and performance. So in larger sections, if you design by the working stress method, is going to give better serviceability and performance. As working stresses are low, serviceability requirements are automatically satisfied and there is no need to check them. So these are the merits of the working stress method. So the next method, this is method 2, load factor method or ultimate load method. The method is based on the ultimate strength of reinforced concrete or RC at ultimate load. Ultimate load is obtained by enhancing the service load by some factor referred to as load factor. So there is something called load factor. In this method, the ultimate load or the collapse load is used as the design load. So we are designing the element for the ultimate load. What is ultimate load? Ultimate load is the maximum load at the point of collapse. So it's also called collapse load. That is the ultimate load. The strength of RC section is estimated from the ultimate strength of the section. This method uses the real stress strain curve and takes into account the plastic behavior of materials. So this method is also considering the plastic behavior of materials. This method gives a very thin sections which result in excessive deformation and cracking. So if your beam has very thin sections and if under the loadings, it is going to give large deflections, right? But if we take wider sections under the load, there are going to be lesser deflections, right? So in this method, we are going to get very thin sections and we are going to result in excessive deformation. So these are the points related to be remembered in the load factor method or ultimate load method, thus making the structure almost unserviceable. So due to the load factor method, the structure is almost unserviceable and this method is not used by designers. So what is the load factor? It is the ultimate load divided by the working load. It is the ratio of ultimate load to the working load. So working stress method, it gives satisfactory performance at working loads and it is unrealistic at ultimate state of collapse. So at ultimate state of collapse, it is giving unrealistic results. So this is a comparison of all the methods. Ultimate load method will provide realistic assessment of safety, but it does not guarantee serviceability. So these are the drawbacks of both the methods. The first method is giving satisfactory performance, however, it is unrealistic at ultimate state of collapse. Whereas the ultimate load method is giving realistic assessment of safety, however, it does not guarantee serviceability. So due to the drawbacks of these two methods, we required a third method, that is the limit state method. Limit state method will give you ultimate strength, serviceability as well as durability. In limit state method, the structure is designed for safety against collapse, for ultimate strength to resist ultimate load. So the structure is designed for safety against collapse and also check for its serviceability at working loads. So that is the limit state method. Limit state method includes working load plus ultimate load. So what is limit state? The acceptable limit of safety and serviceability requirements before failure occurs is called the limit state. So the limit state is the acceptable limit of safety as well as serviceability requirements before the member reaches failure is called the limit state. The two important limit states to be considered in the design are limit state of collapse and limit state of serviceability. So we have to prevent the structure from collapsing and at the same time it should be serviceable. So the limit state method, that is acceptable limit of safety and as well as serviceability requirements before failure occurs. So in the limit state of collapse, we have the provisions for flexure, shear, compression, torsion, tension and bond. We have to design the structures for flexure, shear, compression, torsion, tension as well as bond. It deals with strength, buckling and overturning. So all these phenomenon is going to be included in the design. The limit state of serviceability. So in the limit state of serviceability, so in the limit state of collapse, you can see that we are going to design the structure for all these phenomena, that is for the flexure, for shear, for compression, torsion, tension and bond, as well as it is going to give us the strength. So all these forces, that different forms of forces, right? Flexure, shear, compression, torsion, tension and bond. These are involving strength, buckling and overturning. So the first one, the limit state of collapse, is going to deal with these problems. That is flexure, shear, compression, torsion, tension and bond. Whereas the limit state of serviceability, the limit state of serviceability is going to deal with deflections and crackings in the members. So whenever there is loading in a structure, you might observe that there is deflection and there's going to be cracking. So limit state of serviceability is to deal with deflection and cracking. Deflection appearance or efficiency of any part of the structure must not be adversely affected by deflections. So we have to prevent huge deflections and we have to prevent cracking. So local damage due to cracking and spalling must not affect the appearance, efficiency and durability of the structure. So we have to prevent the structure from getting cracking, that is because the appearance is going to be deteriorated, the efficiency of the structure is going to be deteriorated, or the durability of the structure is also going to be affected. That's why we have to prevent cracking and we have to prevent deflection. So when we say limit state of serviceability, it deals with deflection, control and it deals with cracking. So durability, this must be considered in terms of the proposed life of the structure and its conditions of exposure. So when we say durability, it means the long-term life, The long-term life, when we talk about durability of the structure, we are talking about the long-term life of the proposed structure and what are the conditions of exposure, whether it is severe exposure, moderate, or it is light. Other limit states. So what are the other limit state? There is excessive vibration. So these cases are occurring in some particular special cases only. So there's going to be excessive vibration, there could be excessive fatigue, and there has to be fire resistance. So excessive vibration which may cause discomfort or alarm as well as damage. Fatigue must be considered if there is cyclic loading. When there is cyclically, there is load acting, right? This is called cyclic loading. So when there is cyclic loading, fire resistance, this must be considered in terms of resistance to collapse, flame penetration, and heat transfer. So whenever there is a case of unexpected fire, the structure should be resistant to fire. There is resistance to collapse, there is flame penetration and heat transfer. The structure should be resistant to fire. These are the different types of limit states for the design of any reinforced concrete structural element. So coming to the term partial safety factor. So what is the partial factor of safety? In limit state design, the load actually used for each limit state is called the design load for that limit state. So the load actually used for the design of each element, that is known as the design load. Design load is the product of the characteristic load and the relevant partial factor of safety. It is called factored load. So if you can see here in this equation, gamma F is the partial safety factor appropriate for loading and FCK is the characteristic load. So when you multiply the characteristic load with the partial factor of safety, that is gamma F, that is the partial factor of safety appropriate for loading. It is called the design load. So you are designing any structure by the limit state design, then you are considering it as the design load. And how do you calculate the design load? The design load is the product of the partial factor of safety multiplied by the characteristic load. So it is design load is the product of the characteristic load and the relevant partial factor of safety for the loads. It's also known as the factored load. So coming to why do we need a partial factor of safety? So what is partial factor of safety or partial safety factor? This partial safety factor is intended to cover those variations in loading in the design or in the construction which are likely to occur after the designer and the constructor have exercise. That means what we calculate during the design is not directly transmitted to the structure. When the structure is constructed, it behaves in a different manner compared to the calculations. It is not an ideal case, right? So whatever calculations are done, it is done based on some assumptions, whereas the structure may behave in a more realistic manner, whereas the calculation may be more idealistic. So there is a gap, right? So to meet that gap, we are using a partial safety factor. This partial safety factor is intended to cover those variations in loading in the design or in the construction. So there is lack of adequate data and there is errors and inaccuracies which may be due to number of causes. So why we need a factor of safety? Partial safety factor, because there may be lack of adequate data and there are inaccuracies or errors. And these inaccuracies are due to these causes, that the design assumptions and inaccuracy of calculation. So that means the designer has taken assumptions. So we know that whatever design we are doing is based on only assumptions. They are not highly realistic, but they are just assumptions and therefore there is going to be inaccuracy in the calculation. there is a possible unusual load increase. So during the construction, there are different conditions, right? Their site conditions may be different. So there is some unusual load increase in loads. So this is one of the possible reasons. There is unforeseen stress redistribution. So there can be some unforeseen reason due to which there is stress redistribution, and there is construction inaccuracies. So during the construction practice, the entire construction is dependent on workmanship. So there can be inaccuracies during construction. The design calculation may be inaccurate, or there can be inaccuracies due to construction practices. So what is the purpose of introducing the partial factor of safety is because we need to find a way to fill the gap between these inaccuracies in calculations and inaccuracies in construction practices, as well as the assumptions that we are taking for the design purpose. So to meet these inaccuracies and to reduce the effect of or to reduce the gap between the real structure and the construction practices, the construction procedures, the assumptions used in the calculations, to meet the gap between all these inaccuracies, we are going to use a partial factor of safety. So in the next session, we are going to discuss about the topics related to the design of different structural members. In this session, we are going to stop here and continue in the next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.